All right, well, we come now to the Incenter Theorem. We've looked at the perpendicular bisector theorem and the converse of the perpendicular bisector theorem, the circumcenter theorem, and the angle bisector theorem. While I'm thinking about it, on the circumcenter theorem, which is created when we got perpendicular bisectors of the sides of a triangle. If it's an acute triangle, I think I meant to mention this in that video, but I didn't. If it's an acute triangle, the circumcenter is going to end up in the interior of the triangle. If it's an obtuse triangle, the circumcenter is actually going to be outside or on the exterior of the triangle. And if we're dealing with a right triangle, the circumcenter is actually going to be on the hypotenuse. Those are interesting facts to know too, to help you recognize where to place the circumcenter or where it should go. Or if you see a diagram with the circumcenter on the exterior of the triangle, you know you're dealing with an obtuse triangle. If it's on the interior, you've got an acute triangle. And if it's on the hypotenuse, you've got a right triangle. Now, what about the Incenter Theorem? Now, the Incenter Theorem states that angle bisectors of a triangle intersect at a point called the incenter. So we're talking about bisectors of the angle. We're talking about angle bisectors, and they will intersect at a point that is called the incenter, and that incenter is going to be equidistant from the sides of the triangle. Okay, it's good to know. Equidistant from the sides of the triangle. Now, so here we go. It says if P is the incenter of triangle XYZ, and that would certainly appear to be the case, because there's P. We got angle bisectors running from here, and from here, and from here, from angles X, Y, and Z, converging together there at that point. It says find each measure. So the first one it wants us to find is PK. Now, since it's the incenter, it is equidistant from the sides of the triangle. So let's see what we've got here. Well, let's see. Would mean that this and this and this would all be congruent. Now, in this triangle right here, let's say P, put this in a different color, P, X, J. And this is a right angle here, by definition, because that's a right angle. Then this is the hypotenuse, and this is a side, but we do not know the measure of that side, PJ. We're asked to find PK. But PK and PJ are going to be congruent or equal to each other. And we got enough information here to find the measure of PK. Now, Pythagorean theorem says that a squared plus b squared equals c squared, where c squared is the hypotenuse. So we know that the hypotenuse is 20. So let's say 20 squared. And let's call this where we got to measure 12a. So we got 12 squared plus b squared. That's PJ. So we're going to try to find PJ and then interpolate that that's congruent to PK by definition of the Incenter theorem. So let's solve here for b squared here. So I'm going to, well, I guess I can go ahead and square these. Let's say 144, which is 12 squared, plus b squared equals 20 squared, which is 400. Well, not 4,000, but 400. And let's subtract 144 from both sides. So b squared is equal to 400 minus 144. And I'll probably need a calculator for that. And so 400 minus 144 is 256. So b squared is 256. And therefore b is going to equal the square root of, because taking the square root, squared and square root are inverse properties, of 256. And we're talking about a distance, so it's got to be positive. And the square root of 256, well, I just happen to know, because I've done it so many times, but you can verify it on the calculator, that the square root of 256 is 16. So if PJ is 16, and we get that from Pythagorean theorem, because we know the hypotenuse and we know one of the sides, we've solved for this side here, PJ, and if PJ and PK are congruent, by definition of the Incenter Theorem, then PK is equal to 16. Shazam. That was a little bit more complicated than I thought when I got into it. All right, let's look at one more other property of the Incenter Theorem before we leave it and move on. All right, so here again we say if P is the incenter of triangle XYZ, and we know that it is, because it is where the angle bisectors intersect at that point P, find the measure of angle LZP. All right, so we want to find the measure of angle LZP. I'll have to do a little work on this. Now, I can see here that this measure, that angle KXP, that angle right there, is 31. And by the definition of the angle bisector, then angle YXZ is going to be twice that, so that's going to be 62. So this right here is going to be 62. And down here I see that angle JYP is 27 degrees, which means that the angle XYZ is going to be twice that. So if that's 27, then that's 54. So this is 54. All right. So then I can find, with that, I can then find what the measure, so the measure of XZY, this angle right here, that whole angle, is going to be equal to 180, because it's 180 degrees in a triangle, minus 62 minus 54. Okay. And I get the 62 from here. I get the, that's a bad looking 5, isn't it? The 54 right there. If I get the measure of this and then take half of that, I'll have the measure of LZP, this little piece of this right here. All right, let's see. I probably need a calculator again. All right, 180 minus 62 minus 54 is 64. And if I take half of 64, so that means that the measure of LZP is going to be 64 divided by 2, which is going to equal 32. So the measure of LZP is 32. All right, those were kind of fun. I like those. You might want some practice on this. You got to think your way through it. Be persistent. Make sure you get plenty of practice. Do it with patience. Don't give up too quickly, and you want to persevere. Using the Incenter Theorem.